All right, guys, so we are moving into Unit 4. In Unit 4, we are going to be dealing with graphs of functions. So before we get started on specific types of graphs, like linear graphs or exponential graphs, we want to just cover some basic terminology. And so you were given a foldable in class, so you'll fold along the dotted lines, and that'll serve as your foldable. We're going to fill in the notes on this packet. So the first word that we're going to discuss is domain, which is the set of all x's that are covered by this function. As you can see, the domain of this function is going to be all real numbers because we can see that it's heading off, the function is, we can tell by the arrows, in both directions, which means all x values, which is this axis, are going to be covered by the function at some point. Then we switch over to range, which is the set of all f of x values, which is our y-axis. And so we can see, again, since the function's heading off in both directions, that all f of x values are going to be covered by this function. So our range is also all real numbers. The next word that we're going to fill in is positive. So positive is down here if you look at the outside of your foldable. And positive is basically saying we are looking for the intervals. Intervals just means range of values where f of x, where our output is going to be positive. So again, we're going to use our x-axis to help us determine that. That's our cutoff point. Everything above the x-axis has a positive f of x value. So here and here, all of these have positive f of x values. So the interval is going to be negative infinity is less than x is less than -3. That's one interval where f of x is positive. That's this interval. Because when we talk about intervals, we talk about the x coordinates that the interval is on. So the interval starts over here at negative infinity and goes all the way up to -3. The next interval that we're talking about is from here to here. That's the next positive interval. So our other interval where it's positive is 0 up until +3. So from x is 0 to x is +3 is positive as well. So let's clear off some space here. Okay, and then the next word that we're going to write is negative. These are the intervals where f of x is negative. So we're trying to see where is this function negative. And so again, our x-axis is the cutoff point. This chunk right here is negative, and this chunk right here is negative. But again, when we describe it, we're going to be looking at the x values. So from here to here, the function's negative. So that interval is from -3 up until 0. From x is -3 up into x being 0. So that's our first negative interval. Our second negative interval is from here onwards. And so this line is x is 3, and it goes all the way up forever to positive infinity. So that interval is 3 is less than x is less than infinity. The next word we're going to do is increasing, which is this fold. So increasing is where, well, let's say intervals. Intervals where f of x is getting larger. So I think of this as like a roller coaster ride. If I follow this roller coaster ride, I'm starting off by going downhill, so my f of x values are getting smaller. Then I'm going uphill, so here my f of x values are increasing. Again, when we refer to the interval though, we use the x values. So we're looking at the x values from here all the way up until here, because this is the values where f of x is getting larger. So that's from x being -2 up into x being 1. So from -2 until 1, the function is getting larger or increasing. Now we're going to look at where the function's decreasing. So decreasing are the intervals where f of x is getting smaller. So again, we go on our roller coaster ride. So here, I'm decreasing. On this part of the function, I'm decreasing. I'm going down. And then again, I increase until this point, and then from here, I go down again. So I have two intervals where my function is getting smaller. This is the first interval, and so this interval starts all the way over at -infinity and heads up until -2. So the first interval is from -infinity up until -2. And then my second interval, always referring to the x coordinates, is this. So from 1 all the way up until forever, this chunk of the graph is going to be decreasing. So we start at 1 and then decrease up until positive infinity. Now we'll talk about end behavior. End behavior is what the function's doing at its ends. So we have two ends. We have this end of the function, and so on this end of the function, this is heading towards -infinity. So for end behavior, we say as x is going towards -infinity, what's the end of my function doing? My function, my f of x values, are going to be getting bigger. They're going to be heading off to, that's an arrow. They're going to be heading off into positive infinity. So as my x values go towards -infinity, my function is actually going to positive infinity. On the other end, as x is going towards positive infinity, so x is going to positive infinity here, what is the end of my function doing? What is this end of the function doing? Well, it's heading towards -infinity. It's going downwards. So f of x is heading to -infinity. And then the last places that I want to label are called relative minimums and relative maximums. Relative minimums mean in the area, what's the smallest value? So here, this is a relative minimum because relative to the rest of the function in that area, it's the smallest value. And then this right here would be considered my relative maximum because it's the largest value in relation to the function in that area. And those are the labels that we give to functions. All right, now with this example, I want you to take your notes from the last page and on a separate sheet of paper, fill in all the vocab words for this function. So make sure you say the intervals of increasing and decreasing, where it's positive and negative. You also need to list the domain and the range. Talk about the end behavior. And then we also need you to identify the relative mins and max.